So I flew here on Sunday. It's a very long flight across the Pacific. One of the great things about that flight is it gives you an opportunity to catch up on your movie watching and reading books. And probably about the only good thing about the flight, actually. And one of the books that I read recently that I found really interesting was a book called 4,000 Weeks by a British psychologist, Oliver Burkeman. And it's called, the subtitle is Time Management for Mortals. But it's not one of those awful self-help time management books that says you should get up at 4 o'clock in the morning, empty your inbox, cross off everything on your to-do list, and then go down the gym. It's more of a sort of Zen, sort of hippie, philosophical guide to time management. And the book points out, as the name suggests, that the average human lifetime is incredibly short. It's about 4,000 weeks in total, and that none of us is going to get done all the things that we actually want to do in life. So really, it encourages you to accept that our time is finite and to embrace the liberation of limits as a sort of path to fulfillment. And I find that kind of quite thought-provoking, to be honest. But about halfway through this book, I've got to admit, I had a crisis, because I started applying maths to my own life, and I realized that I am so incredibly old that I'm nearly 70% of the way through my allotted 4,000 weeks, and I've probably only got 30% left. And I've got to admit, I felt a little bit queasy at that point, so I had to sit down and have a glass of wine to think about it. But then I started thinking about it in the context of this presentation and how the world is changing so incredibly quickly. And I said to myself, you know what? I reckon I'm going to see more exciting things, more innovation, more amazing things in this world in the next 30% than I have in the 70% to date. And I felt a bit better about that, so I had a glass of wine to celebrate. It was fantastic. But does anybody else kind of feel overwhelmed by their tech news feeds at the moment? I mean, yeah, I wake up every day and it seems there's something incredible happen. I mean, this morning I got up and the tech news was full of the NVIDIA conference that happened yesterday. Somebody called it the AI Woodstock. And NVIDIA, they booked out an entire sports center in San Jose. It was more like a rock concert than an AI technical conference. And Jensen Huang, the CEO, stood up and he talked about the next generation of NVIDIA chips that are going to power amazing AI type of stuff. People can't get enough of that guy. He's like a rock star. I think he's the tech Taylor Swift, to be honest. He's so popular. And here's an example of where things are changing so quickly. So did anybody actually come to this summit last year at this venue? A few of you? Yeah. Well, I don't know if you came early, but I gave a presentation last year on the future of network security. And I came up with this really good strategy for the end of my presentation. I thought, I'm going to wow the audience by taking advantage of generative AI to create the final image for my slide. And everyone's going to be speechless and wowed by my presentation. So I used the tool at the time called DALL-E, that I'm sure many of you have used, and I gave it this prompt. Create a picture of people working harmoniously to build secure future networks. People were speechless. This is what it generated. Okay, let's be honest, it's not that amazing. But it's not bad, it's kind of cute. It's not the kind of networks that I had in mind, if I'm honest. But, you know, it kind of shows people looking happy, working together. You know, I thought it was okay. 12 months have passed since then. And a few weeks ago, OpenAI announced a new generative tool called Sora, which not only generates images, it can actually generate video. So you can give it a prompt like this. Cinematic trailer for a group of adventurous puppies exploring ruins in the sky, and it will create this. Now, I don't know about you, I think this is absolutely breathtaking. This is approaching Hollywood levels of animation. Pretty cute puppies. Everyone's a sucker for a puppy. That's why I chose it. So that's in 12 months. Tyler Perry, who's a Hollywood mogul, when he saw what Sora can do, he announced that he was immediately pausing plans to invest nearly $1 billion to expand his Hollywood studio because he needed to think about the impact that this technology would have on the future of movies and animation. AI video may have officially disrupted Hollywood. I mean, 4 years ago, we thought that computers would never be creative. I remember my daughter was about to go to university in Australia, and my wife and I sat down with her, and she was not sort of science-y computer type of girl. She was great at acting and dancing, and she was deciding what degree to do. And we said to her, you know, honey, computers may take a lot of jobs, but we're always going to need people to be creative, and computers will never do that. Maybe that wasn't such good parental advice. In hindsight, I don't know. And then 2 years ago, we said, okay, maybe they can be creative, but there are some uniquely human characteristics that computers will never mimic, such as empathy. That's a uniquely human characteristic. And then the American Medical Association journal ran a test. They looked at a bunch of medical questions that had been posted to a social media forum, and they got some physicians to answer them, and they got some chatbots to answer them as well. And then they got a second group of physicians to blind rate the answers that each group had given. You can probably guess what happened next. The evaluators preferred the chatbot responses nearly 80% of the time. And they pointed out that they were much better medically technically accurate answers, nearly 4 times better than the physicians gave when asked the same questions. But this is what really got me. They were also rated as significantly more empathetic than the doctors. Nearly 10 times higher prevalence of empathetic answers than the physicians. Maybe human intelligence isn't quite as special as we thought. So it seems to me that my word for 2024 is going to be shocked, because it seems that like every day we see rapid, unanticipated advances in a whole range of fields that even the experts didn't see coming, and that the unexpected is probably going to be the new norm. Mustafa Suleyman is one of the co-founders of DeepMind, the Google company, and he's written a book about this. It's one of the best-selling business books last year, called The Coming Wave. His theory is that we are on the edge of a tidal wave of massive acceleration in a range of technologies that, in his words, will essentially upend the entire post-war economic security and economic order, and will be the largest transformation of our lives. Well, that's a pretty big statement, isn't it? I mean, how can that possibly be true, really? But then he goes on to explain why he thinks that. And he thinks that we're going to see significant progress in a whole range of different technologies: robotics, quantum computing, synthetic biology, of course AI, and new energies, and that progress in any one of these technologies individually will be impactful. But when they occur together, they all kind of boost, reinforce each other, and everything accelerates in ways that are essentially entirely unpredictable. Other people agree with this. It's called the law of accelerating returns, in which you create these feedback loops of technologies which kind of grow and accelerate. Here's a couple of examples of the sort of thing that they're talking about. So this is a company, one of many startups called Figure.ai, that is building humanoid robots. So we've built a human-centric world, a world that is designed for our bodies, our physical shape. So it makes sense that if we're going to build robots to exist in this human-centric world, they'll better integrate if they look and act like us. So Figure recently received $700 million of funding from Jeff Bezos, from NVIDIA, from Microsoft and others to build these human robots. And they recently announced that they're integrating OpenAI's AI models into these robots. So these OpenAI models will have large language models embedded in them. They'll be able to understand language. They'll be able to speak back to us, and they'll have advanced reasoning capabilities. And progress in robots has been accelerated recently because of the falling price of sensors, actuators, and of course, massive advances in AI software. So Peter Diamandis, some of you may have heard of him, he's the president of the X Future Fund. He predicts that within the next 10 years, we will start to see these in our workplaces and our homes in the hundreds, the thousands, and eventually millions of them. They'll fill labor shortages. They'll do dangerous, dirty work that humans don't want to do. And of course, they'll work 24/7 and they'll never phone in sick. All sounds pretty good, except we've all seen the Terminator movies, haven't we? Energy transition is one of the key challenges that the human race faces if we're going to overcome climate change. Massive progress has been made in renewable energy in recent years. My understanding is that renewables will be the single largest source of electricity generation within the next 2 years, which has been driven by the falling cost of solar panels. But of course, the holy grail of energy generation is fusion, nuclear fusion, the same chemical process that powers the sun. And scientists have been working on fusion for many years. It's one of those technologies that always seems to be 20 or 30 years away. But significant progress has been made recently. This shows a tokamak reactor. It's a donut-shaped reactor in which scientists smash atoms together, controlled by magnets, went into a gaseous kind of plasma. And when that plasma is stable, the atoms will fuse and generate huge amounts of energy. And if this plasma can be kept stable, fusion reactors will create almost limitless green, safe, and clean energy that will literally transform the entire planet. Because when you think about it, a lot of geopolitical tensions are kind of driven by energy supply concerns all over the world. You know, we've seen that in Russia with gas, Germany, etc. But the problem with this gaseous plasma is that it's very, very unstable. It tends to collapse or tear. And scientists have been trying to solve this problem for years. But recently they took a novel approach to it. They thought about the way that AI is used to play games, like chess or Go, using a technique called reinforcement learning, where basically you get a computer to play a game millions and millions of times, and every time it makes a move that leads to a good outcome, you get a positive reinforcement. And every time it makes a move that leads to a bad outcome, you get a negative reinforcement. And those techniques are very powerful in building very capable game-playing engines. So these scientists thought, what if we gamify nuclear fusion? What if we give a computer the challenge of keeping this plasma stable and coherent so that the atoms will fuse and generate energy? And a paper was published in February, just a few weeks ago, demonstrating that applications of reinforcement learning to nuclear fusion have been able to avoid fusion plasma tearing using the same techniques, reinforcement learning. So it appears that one of the many obstacles towards safe energy generation may be overcome by combining AI with fusion. Pretty amazing. And here's a paper that is probably very relevant to this community. I didn't expect to see it. It came out 3 weeks ago from a group of cryptographers working at IBM, including the legendary Whitfield Diffie, one of the co-developers of the Diffie-Hellman encryption agreement, of course. And the title of the paper is Advances in Quantum Computing and AI May Impact PQC Migration Timelines. And they point out that by combining different technologies and advances in them, the synergistic combination of these approaches may lead us to question the post-quantum timelines that we've been working on for the last 7 or 8 years. And they give some examples how you can apply quantum algorithms, such as Grover's algorithm, with classical computing and advances in AI and machine learning, such as adaptive search. And they gave an example of an algorithm called Grover's adaptive search, which is a faster search through a key space. And using techniques such as this, they concluded that lattice-based cryptography, which is the maths at the heart of the next generation of post-quantum cryptography, and even symmetric ciphers like AES may not be quite as robust as we thought they would be. And we may have to revisit some of those timelines. Technologies evolve, technologies collide, and everything accelerates. If you think about technology over the long run, it's kind of easy to forget that it wasn't always this way. Our ancestors probably used the first wave of technology 3 million years ago when they invented the primitive hand axe, tools that they could use to kill animals and prey more easily. Their brain learned to develop fine motor skills to control those tools, which led to creative outputs like cave paintings, sewing, and carpentry, and evolved the brain with those 5 motor skills. It took 1 million years before they learned to manage and control fire. And fire was a pivotal moment in the evolution of humans. Cooking food releases energy far sooner and more efficiently than chewing it raw, which led directly to the development, evolution of the brain and cognitive skills. And sitting around a fire was a warm, safe point of focus for our ancestors that encouraged socialization and the building of communities. But if you look at technical innovation on a flat timeline, almost nothing happened for millions of years, and all of the action is up there on the right-hand side. We live in an extraordinary time in history. And of course, for much of that history, progress was measured in manipulating material, physical goods in the world to improve life. So from fire to electricity, from hand tools to machine tools, the invention of the wheel, the Industrial Revolution, and large-scale manufacturing was all about manipulating physical goods in the world. But then, in the middle of the 20th century, technology began to operate at a higher abstraction layer, with the realization that information is a key component of the universe. Information can be written down in binary form, and in the form of DNA is actually at the core of life itself. So slowly we saw that bits and now genes have replaced atoms as the building blocks of innovation. And we've now evolved to a stage where we can literally engineer intelligence by building advanced AIs. And very soon we will be able to engineer life through massive progress in synthetic biology. So synthetic biology is a technology that hasn't really captured the public imagination in the way that AI has, but I suggest it will be just as impactful, if not more. It's basically about the application of engineering principles to biology itself. So DNA sequence takes biological information and turns it into text that is readable by humans and computers. The human genome sequence, for example, laid bare the entire genetic sequence of humans. And the cost of DNA sequences, unbelievably, has fallen 1 million times in the last 20 years. That's 1,000 times faster than Moore's law for comparison. But it's not just about reading DNA sequences. We can now actually create new DNA sequences using technologies such as CRISPR, which is a kind of genetic scissors. It allows you to look at the DNA of any kind of organism and change it to edit the DNA sequence and literally create new life. So we're rapidly seeing advances that are democratizing access to engineering life. Companies such as Odin will allow you to buy over the internet a home genetic engineering kit. You can start playing with some of this stuff. When I was a teenager, I was playing with early home computers and microprocessors in my back bedroom. And of course, we all know the stories of Apple and IBM and Hewlett-Packard that famously started with a couple of people tinkering with electronics in their garage. I feel like we're kind of at this state with biology today. Very soon, you'll be able to buy DNA printers that will allow you to print new DNA sequences. Now, I'm sure we can all imagine the amazing possibilities of this kind of technology. Maybe algae that can extract carbon from the atmosphere. Maybe viruses that can grow into batteries, or proteins that will purify dirty water. And of course, the promise of major advances in medicine, such as personalized medicine, which is tailored to our specific genetic sequence. In fact, in December last year, the first genetic modified CRISPR medical technology was approved for use to treat sickle cell disease. A single editing of a gene in people with sickle cell disease looks like it will actually cure that in individuals. And I believe there are a lot more in the queue to get approved. But for all the good things, I'm sure a few of you are sitting here thinking, okay, what other stuff could you do if you can manipulate life? I was in Tokyo last week on business, and tomorrow is the 29th anniversary of a major attack on the Tokyo subway by members of a death cult. They released sarin gas in the middle of the Tokyo subway, killed 14 people, and very badly injured 1,000 more. Group of crazy people, death cult, sarin gas. So what could people with malicious intent and the capabilities using this kind of technology do in their back bedroom, we have to ask. And it was interesting, just last week as I was putting these slides together, I came across this article where 90 biologists got together and they issued a joint statement saying that we see the potential for the downside of this technology and we have to balance the good and the bad. So they collectively came up with a statement articulating a set of values and guiding principles that they will self-adhere to try and have responsible development of this kind of technology rather than leading to bioweapons. So I think it's interesting that, charters like this really expose the double-edged sword of progress and rapid acceleration of technologies. On one hand, you wake up in the morning, excited about the day, moving as we accelerate towards a tech-driven utopia. On the other, you wake up scared to read the news because you're worried about what a state the world is in, and will technology accelerate that? And I think it's clear that there is a sort of split in worldviews as to how we should handle this rapidly changing world. A kind of chasm has developed between tech ideologies. And it's probably the defining challenge of our era as to how to resolve this challenge. And I think it's probably, whichever side comes out on top of that challenge is probably going to shape the way the world unfolds over the next decade. So I think it's useful and important to talk about it and understand both perspectives. So on one side of the argument, we have the techno-optimists, who maybe are best, the most famous of whom is probably Marc Andreessen. Marc Andreessen is the famous original developer of the Netscape browser, the first ever Netscape browser, and now he's a legendary venture capitalist working at Andreessen Horowitz. And in October last year, he published what he called his Techno-Optimist Manifesto. It's a very long document, so I just took a few snippets from it. He says, "It is a truth. Our civilization was built on technology. Our civilization is built on technology. Technology is the glory of human ambition and achievement, the spearhead of progress, and the realization of our potential." At this point, I feel I should have the Ride of the Valkyries playing in the background. He goes on. "For hundreds of years, we properly glorified this until recently. I'm here to bring the good news. Blah, 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 blah. It is time to be techno-optimists." This is just a tiny slice of what he said. Techno-optimists take the view that everything that we enjoy in our modern world, food, access to food, ability to travel around the world, amazing technologies, transport, cars, has been driven by innovation in capitalist societies and by taking advantage of progress in science and technology developments. And they argue that to solve our current and future challenges, we should realize this fact and accelerate as fast as we can to take advantage of progress and build technologies that will take us to some future utopian state. This utopian state can be imagined in several sci-fi series. Has anybody read the Culture series by the Scottish author Ian Banks? Interesting series of novels. It's set in a post-scarcity civilization where humans are an interstellar species, intermingled with humanoids who do all the work, do all the dirty, dangerous jobs. It's post-scarcity, so there's limitless energy, limitless food, limitless access to clean water. Everything is in abundance. And humans are liberated from the chore of doing work, unless they want to. Some people may want to. And they're free to pursue lives of creativity and follow their passions wherever they want. And this entire universe is overseen by these super intelligences that are benign and programmed to sort of worship human beings and to keep them safe. Amazing. Sounds pretty good. So, the promise of these technologies, I would guess that most of us would agree that everything that we see in this room, in this world, has been driven by progress in science and our ability to capture and manage that. There are a lot of billionaires in the techno-optimist category. And I'm sympathetic to this view, but I do think you have to pause and ask, what about the moat of fire? Because whilst in public, all of these billionaire tech elites are extolling the benefits of their businesses and their organizations and how they are creating the world, in private, it seems they're actually preparing for something very different. They're preparing for the breakdown of society, and they're building apocalypse bunkers. Now, no judgment, just a quick survey amongst the room. Is anybody here got an apocalypse bunker? I won't judge you, it's fine, yeah. Basement? I don't have one, I'll be honest. I'm not really built for battle, I've decided, to be honest. I can't really function unless I have 3 coffees in the morning, and pollen can sometimes be a problem. So I'm just not going to be very good in this kind of world. So I just have to hope it never happens. But I do think you have to ask, what does it mean about progress when the elites in this world are saying one thing and in private are actually preparing for something else? By contrast, the tech pessimists or the tech skeptics, they don't really have a written manifesto, but their view is kind of easy to understand. They think that tech will take all of our jobs and probably kill us in our sleep. Yeah, pretty straightforward, easy to understand. Okay, it's a bit of an exaggeration. I've simplified it. The tech skeptic view says that, okay, we may live in the most advanced society on this planet's history, but if that's so good, how come we can't talk to each other? And they will point out that the benefits of progress are not evenly distributed. And we live in a world where growing inequality and social unrest basically means that trust in governments around the world has essentially collapsed, it seems, at the moment, threatening democracy and the rise of authoritarian leaders all over the world. One of the big concerns this year, of course, is the impact of AI spreading misinformation on elections around the world. This is a bumper year for elections. There are elections all over the place, not just in the USA. And The Economist magazine did a survey on this recently because they wanted to understand how impactful AI could be on elections. And their conclusion, which really surprised me, was that they didn't think it would be impactful at all. And I said, this can't be right. How can they draw this conclusion? And then I read the reason they said that. And they said, we don't think it will be impactful because trust is already so low, and faith in governments and information is already so low that we don't think a bit of AI and misinformation is going to move the needle. I'm not sure I agree with that, but that's what they said. So, the tech skeptical view basically says that both at the individual level and at the institutional level, society is not ready for a rapid acceleration of new technologies, and that we should slow down, take our time, and have a well-considered approach to these technologies rather than accelerating full bore. The example of the tension between these two worldviews was made physical over the course of one crazy weekend last November, which I'm sure many of you followed. This is the best reality show in tech at the moment. It was a hell of a weekend for nerds. I loved it. So what happened was, if you didn't follow the story, over the course of one weekend, the board of OpenAI, arguably the most consequential company in technology at the moment, fired their rock star CEO, Sam Altman, for some unspecified reason. Chaos ensued. Over the course of a weekend, the company went through 4 CEOs. Rumors flew thick and fast, and eventually Microsoft stepped in as the adult in the room because they've got a $10 billion investment in OpenAI, so they had to get it under control. By Monday, Sam Altman was back at the CEO, and they were looking for a new board. What a weekend. It's still the best reality show in tech, by the way. They're currently being sued by Elon Musk because he says that they're not open enough. And he says he'll drop his lawsuit if they change their name to Closed AI. So I don't know if that'll happen. So we don't know exactly what happened. Rumors were that maybe OpenAI had actually created artificial general intelligence, a computer so incredibly powerful that when the board saw it, they felt they had no choice but to fire the CEO and stop progress because of the possible implications. Now, the board at that time was famously populated by effective altruists, a group of people who are on record as saying, we should slow down a little bit and take time to consider how progress can best affect humanity. So, at the end of the day, I suspect it came down to a very mundane story about some personality clashes between individuals. We don't really know. But I think this is a really important story because it shines a spotlight on a pivotal moment in history where we face this tension between how fast we accelerate or how much we slow down and think about this. And there was another kind of important moment that happened earlier last year. Does anybody know who this gentleman is? He's called Geoffrey Hinton. He's sometimes known as the godfather of AI because he's one of the leading AI researchers. He led a team at the University of Toronto that developed deep learning technology, the core technology at the heart of modern AI applications. Geoff Hinton was working at Google, and then in the middle of last year, he suddenly quit, unexpectedly. And he gave a very interesting reason why he quit. He said he was so shocked, that word again, shocked. He was so shocked by emerging properties of large language models such as ChatGPT that he could suddenly see all sorts of unanticipated risks that weren't clear to him before. And he felt that he had to leave Google so that he could publicly talk about them and explain why he felt like that. And he then went on to give a series of very specific technical and philosophical reasons why he felt that way. And I just found these so incredibly interesting and thought-provoking that I want to talk about them with you. But to do that, I just want to make sure that we're all on the same page. So if you'll excuse me, I'm going to give a very, very brief amateuristic explanation of the history of AI. And I apologize to any AI engineers in the room. I'm certainly not one. So please forgive my mistakes. Artificial intelligence, the discipline, has been around since the 1950s. In fact, I remember interviewing for a job in the UK in the 1990s at a company that was building expert systems. And it was thought that the best way to build artificial intelligence was actually to create domain expertise in a particular area, get as much information as you can, embed it in some sort of database, and then put an access layer on top of it so that we could ask questions of it and interrogate that database. Well, I didn't get the job. And it turned out that expert systems weren't the answer to building artificial intelligence anyway. And it wasn't until this century when people figured out that instead of sort of force-feeding computers with knowledge, the best way to get them to learn was to get them to learn the information themselves using a technology called machine learning. So for example, if I want to build a bird photo detector, I'm not going to describe what every possible bird in the world looks like. What I would do is I would create a labeled set of pictures of birds, and then I would create a whole bunch of other images of things that are not birds, and I would feed that to the computer, and it would slowly learn what are the key features of a bird that is endemic to the bird itself so that it can actually predict what a bird would look like on an unseen picture. And it seemed that that approach was very fruitful, and a lot of progress has been made. So at the heart of every modern AI architecture is a technology called neural networks, which is a computer architecture that's sort of roughly modeled on the way the brain works. And you can think of a neuron as a sort of simple evidence-weighing machine. So here's what it looks like. It takes some inputs, and it weighs up the importance of those inputs, and then it produces a single output. This is a bit like the way humans make decisions. Let's say you're all deciding, should I come into DC this weekend or should I stay home? You'll probably weigh up a bunch of factors to decide if it's worth making the trip. You might think about whether any of your friends or family are going to be in the city at the weekend. You might look at the weather forecast. Is it going to be sunny? Is it going to rain? And there might be one factor that is more important than all the others put together, like is Taylor Swift playing or is your favorite sports team playing? That's exactly what a neuron does. They're not very useful on their own, but what Geoffrey Hinton and his team worked out was that if you create a network with millions and millions of these neurons, you can stack them in layers, and the computer will essentially be able to learn from the information that it is trained on and begin to understand the world as a hierarchy of concepts. For example, in a bird detector, one layer of neurons would start to look for edges in a picture that you feed it. The next layer in might start to look like shapes that look like beaks in birds. Another layer might start to look for shapes that look like feathers, and so on at a massive scale. And this kind of technology has proved so effective that it is at the heart of all modern AI systems. And if we look at progress in AI over the last 10 years, we've been very successful at labeling and organizing information using this approach. So you've been able to give neural networks messy information like pictures, audio, video, and it's been very, very good at building internal representations of this information and labeling it. That's why we can get our phones to, search for labels in pictures, because it's using this categorization technology. And this labeling was foundational for the next generation, the current generation of AI, which is all about creating information, creating content. What about language? Well, for many years, linguists said that you can't apply these kind of statistical techniques to language because language is special. People like Noam Chomsky used to say that. Turns out they were wrong. A large language model like ChatGPT is just a type of neural network. It's a very, very large neural network. And instead of feeding it images, you basically give it an awful lot of words, essentially the sum of all human knowledge, if possible. So training a neural network in a large language model is a bit like creating a compression of the internet. It's not actually compressing the internet in the way that we think about compressing a file, but it's creating a lossy representation, a kind of zeitgeist of what the internet looks like. And it turns out that these kind of models obey a very, very simple scaling law, which is the more data you input into these models and the more compute you can use, the more capable they are. They scale very, very predictably. And at the moment, it's not apparent that there are any limits to this scalability. That's why we're seeing a gold rush on AI chips and GPUs. That's why Jensen Huang is the tech Taylor Swift, and the NVIDIA share price has more than doubled in the last year, and why he's acting like a rock star at a sports stadium yesterday. There's a kind of gold rush to build silicon. So of course, that means that the tech giants run the largest models because only they have got access to that infrastructure. But we're seeing a development, very rapid progress in open source models that you can run on your laptop. They're about 18 months behind the large language models. Very, very capable that we can all run. If you're interested in looking at more technical details, just a quick recommendation of a fantastic 1-hour video by Andrej Karpathy. It's on YouTube. He gives the best description of large language models I've ever heard, so I really recommend it. It's brilliant. And he points out that any of us could actually download an open source large language model. For example, Meta publishes the Llama 2 70B model. And if you were to download that and open it on your laptop, you'd essentially see, this is a bit of a simplification, but you'd basically see two files. You'd see a small computer program, maybe 500 to 1,000 lines of C code, and then you'd see a very, very large file that contains the parameters or the weights. So the model name, Llama 2 70B, tells us that there are 70 billion parameters or weights in this open source model. Each weight is a 2-byte floating point value, which means that to store all of these weights, we need a 140 gigabyte file. You could store that on a large disk, run it on your laptop. And it is these weights where the magic happens. They are the brain of these digital intelligences. Everything that is amazing about these devices, creating that video, passing legal exams, passing medical exams, showing more empathy than us, it turns out is somehow encoded in a very large table of floating point numbers. Looks like maths really is the master of the universe after all. And you can store this in a CSV file, a comma-separated file that you can open with Excel. I just find that so incredibly interesting. So if we go back to Geoffrey Hinton now and just talk a little bit about what he said, he made this statement. He thinks that digital intelligence may be better than biological intelligence. And he points out that something like GPT-4 has about 1 trillion connections between the neurons in that deep neural architecture, where it's estimated that the human brain has somewhere between 100, maybe 200 trillion connections, synaptic connections between our biological neurons. Yet, GPT-4 knows far more than any one human. It can pass pretty much any professional exam that you throw at it. It can create poetry. It can create incredible images. So his conclusion is that it appears that the neural network architectures that we train using an algorithm called backpropagation is actually far more efficient at learning and compressing information than we are. That's his first point. Now, at this point, you may be going, this is rubbish. I've used ChatGPT, and it's just a glorified autocomplete. A stochastic parrot, somebody called it. Because you can give it something like, what is heavier, a kilo of water or a kilo of air? And you might get a nonsense answer like this. A kilo of water is heavier than a kilo of air. Wrong. That's wrong. Actually, I don't think you'd get that answer today. This is probably from an earlier version of the model. They're getting better all the time. But there is no doubt that they do hallucinate or create confabulations. They don't give you perfect truth. In fact, they have a very, very strange user interface. Somebody said that they have Battleship as a user interface. You know that game where you've got a screen and you're trying to guess where your opponent's battleships, and you say C4, and they go hit or miss? Well, that's kind of the experience of using a large language model. You ask it a question, and it gives you a great response. You go, that's a hit. And then it says something stupid like the previous slide, and you go, well, that's a real miss. So they don't give you perfect truth. They give you a kind of near truth. But it turns out the near truth can be very, very useful. And I'd say to you, is that so different from the way that human brains work? So, honest question. Has anybody here had a conversation in the last month which you've thought about afterwards, and you thought, damn, I wish I hadn't said that? Or, I wish I hadn't used that word, or why did I put my foot in my mouth? I do it all the time. Just ask my wife. So, there have been studies on the way that human memory works. Like, I don't know exactly what I'm going to say on the next slide. You know, I've thought about it, but I don't know exactly what words are going to come out. It's not entirely predictable in advance. So there was a famous study done of a guy called John Dean. Anybody know who John Dean was? Somebody does. He was the counsel to President Nixon during the Watergate crisis. And he gave a very explicit and detailed testimony to the Senate inquiry on Watergate. Very, very detailed answers, because he lived through the period and he remembered a lot of the facts that had happened. But it turns out that what he stated and is on record as his statements, a lot of the information at the time was actually recorded as well on a tape recorder. So a few years later, a psychologist called Ulrich Neisser wrote a book called Cognitive Psychology, where he used this as a case study. And he compared the transcripts of John Dean's memory with the transcripts of the tape. So the actual fact-based of what had actually happened versus what John Dean recalled. And he found that John Dean gave a pretty good recollection of what had happened, but it wasn't perfect. He made mistakes. His answer was a little bit hit or miss, a kind of near truth. And this was a perfect example of several in this defining book about cognitive psychology, which concluded that human memory is not a perfect snapshot of events. It's not like bringing up a photo on your phone that you took yesterday. We reconstruct memory from shreds of information that we pull out. And sometimes it's right, and sometimes it's wrong. So quickly back to Geoffrey Hinton, he points out that these weights, these digital brains, mean that we've effectively created immortal intelligences. Because these weights can be copied and stored in many locations all over the world. And all you need is some sort of hardware to run them on, and this intelligence will live forever. And he points out that there are implications of immortality, such as robot soldiers who aren't afraid to die, unlike humans. And then his final point was that you can have multiple AIs working on different tasks at the same time. And every time one of them learns something, they will grow their brain by updating the numbers in that table, in that weights table. And then they can instantly communicate that new knowledge with other AIs nearly in real time. So imagine a group of humanoid robots all working on different tasks, learning things. They can share that information. So we kind of have the ability to create immortal AI hive minds. When one learns something, they all learn it. Think about how we share knowledge. Has anybody here run a training course recently where you've tried to get knowledge in your brain into some other human's brain? God, it's frustrating. You just want to dump your brain into theirs, but we're limited by human language. I have to articulate facts that I know in a way that hopefully you will understand based on your knowledge and experience. And then you have to take them in, process them, and ask me questions. It's so primitive and slow. There have been studies done about the bandwidth of human language communication. I was really interested in this because I wanted to know, do some languages, are they inherently more efficient than others? Like, is Mandarin more capable of transmitting information than English? Because we all know that Eskimos have got 1,000 words for snow, for example, like that. So maybe some languages are structurally better at communicating information, which it seems to me would give those speakers a significant advantage, evolutionary advantage. Well, it turns out if you read studies about this, all languages essentially have the same information carrying capacity, which is 39 bits per second. 39 bits per second. And that's in the best case. So compare that to AI hive minds. So he finished with this very provocative statement. He said, human intelligence may just be a necessary step on the evolution to digital intelligence. I just find this so incredibly thought-provoking and a little bit scary. So the question is, do we face existential risk from a CSV file? Microsoft's got a lot to answer for. Okay, what do other AI researchers think about this? Maybe you're thinking this is all hyperbole, this is overstated. Well, there is an annual survey of AI researchers that happens every year. The logic behind it is that if you ask the best and the brightest working in AI to make predictions on what's going to happen next in AI, you'll get a kind of zeitgeist of what is likely to happen. So they do this every year. They ask 2,000, nearly 3,000 researchers to make predictions on the feasibility of a whole range of different milestones, including when AI will automate all human jobs, when can a machine do every task better and cheaper, blah, blah, blah. And we don't need to go into the details of these, but what really struck me was if you compare the predicted dates between 2022 and 2023, 2022 is the blue dots, the timeline on the right. 2023 is the red dots on the left. And this shows that within the course of 1 year, the predicted dates when all these tasks would be achieved has come in significantly in 12 months. In fact, many of these dates are predicted to come a decade sooner than was predicted even 12 months ago. So what I take away from this is that even the best and the brightest don't have a clue what is going to happen in AI, and the unexpected will increasingly be the norm. So how do we think about this? The famous French philosopher Paul Virilio, he said, when you build a ship, you also invent a shipwreck. When you invent a plane, you invent a plane crash, because every technology has attendant risks with it. And even if you're a tech optimist, which I'm inclined to be, we all have to consider methodically and logically, I think, the downsides of these technologies. So we do this in cyber all the time. It's called risk management. So we can imagine considering all of these risks of these technologies like synthetic biology and AI, and we can categorize them into risk buckets, from existential risk down to merely catastrophic risk, etc. This is part of what standard cyber risk management would do. And then I'm sure all of us could sit here and we could all come up with various risks, from autonomous weapons systems to super intelligent AIs, and we could categorize them in one bucket or another. But what I'd like to make the point is that none of this is endemic to the technology itself. It's all about how we as a society decide to build and use these technologies. Maybe this is useful. I think it's useful to think methodically and structurally about the risks, but really it's about how we choose to build them and deploy them is where the decisions have to be made. So undoubtedly, we need to think about containment. How do we maximize the benefits and minimize the risks? And we're going to need a toolkit of technologies and approaches to manage this. Regulation is, of course, going to be critical. I think last week the European EU AI regulation was ratified into law. You can already see the optimists and the pessimists arguing about this. Some argue it doesn't go far enough. Some argue it goes too far. At least there is something now. The industry itself, us, we need to think about how we can self-regulate and start building safety and risk management into the technologies that we build. A few years ago, there were no researchers working full-time on AI safety. Today, some of the best and the brightest are working full-time on AI safety, such as Ilya Sutskever at OpenAI, for example. And of course, it's all about education and awareness. I think we need to be talking it more at events and forums like this and educating ourselves. And my personal advice is to experiment, experiment, experiment. Take every opportunity you can to get to know these tools. Use them in your daily life. Start understanding what they're good at and what they're bad at. Because the more we all understand it and can talk about this, the better we'll be. And there are challenges. You know, an AI regulatory standard in Europe doesn't say anything about what China or Russia are going to do. Undoubtedly, with the current geoclimate, there are challenges. And these open source AI models are going to proliferate. And as we get closer to more capable intelligences, they will become dangerous. And I haven't heard anybody talk about how we can manage the proliferation of open source AI models. So my personal opinion, I think starry-eyed tech utopianism or doom-mongering tech pessimism are not particularly helpful. I would advocate for pragmatic optimism, hoping and believing that we will see a net benefit from all of this incredible progress that we're about to see, but still thinking all the time about the possible risks. Personally, I'm very excited about the remaining 30% that I have left and hope to see great things. But one thing is for sure, nothing is going to be the same. Everything is accelerating. So as the song says, don't stop thinking about tomorrow. Yesterday's gone. Yesterday's gone. Thank you very much.
All right. Great presentation as always, right? I'm not sure whether to be terrified or not. One thing I am going to ask ChatGPT, though, is Julian a Swiftie? We heard that a bunch of times. So we're going to take a little break, probably till about 10:30. So the teams and our sponsors have spent a lot of time setting up some of the exhibits, so please circulate around and chat with them and see what they have to offer. Thanks. See you at 10:30.